Well, hello, geometry. Today is day 16 of your AMI packet. Okay, day 16 has to do with Sohcahtoa. It's your favorite. I knew it. You didn't even have to tell me. I just knew it. All right, so Sohcahtoa. For this, we're going to start off finding side lengths. First thing you need to do in your calculator, make sure it's in degrees. You know, those radians mess us all up. So we're going to hit mode. It's right there next to your second key. And we're going to make sure it's the third one down that degree is highlighted. Okay? Once you do that, you can clear out. And then we're going to get started on our problem. Okay. So Sohcahtoa, sine, cosine, and tangent. We're going to identify what we have going on first here in our diagram. I know that the side directly opposite my right angle is my hypotenuse. So since it's my hypotenuse, I know I have to use either sine or cosine because both of those deal in hypotenuses, hypoteni, something. And then my 11. Remember whenever we talked about what an opposite side was and what an adjacent side was? Adjacent means right next to. So is 11 right next to 37? And it is. It's one of the sides that makes up 37 degrees. So this is my adjacent side. So since I know my adjacent side, I'm looking for my hypotenuse, I know I'm going to use cosine. So I'm going to write out my problem. So cosine of 37 degrees is equal to my adjacent side, which is 11, over my hypotenuse, which is x. Now, since x is on the bottom, I know the last thing I'm going to do is I'm going to have to divide. Whenever I'm setting this up, I am going to put this over 1 because I know that anytime I have any sort of number whatsoever, if I put it over 1, it's the same as just writing itself. And I'm going to cross multiply. Okay? X times the cosine of 37 equals 1 times 11. Okay, once I get there, I need to get x by itself, so I'm going to divide by the cosine of 37 on both sides to find out what x is. And I'm going to type this in exactly how I see it here. 11 divided by the cosine of 37 and hit enter. And I get 13.7734 blah, 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 blah. And I think you just have to round to the nearest tenth. So x is equal to 13.8. So I know this hypotenuse right here is 13.8. Okay, so here's another one. In this example, I'm looking for my x, which is right here. And I'm going to think to myself, what are the parts of this diagram that I can label? All right, I know that directly across from my right angle, this is my hypotenuse. I don't even have anything in my hypotenuse. There's no x there, there's no numbers there, there's no nothing, so I don't even really need it. So I do not have to use sine or cosine. And by process of elimination, that just leaves me with tangent. So let's look at this 32 degrees. From 32 degrees, the side that helps make up that angle is 13. So I know this is my adjacent side. And opposite 32 degrees is my x. So this is my opposite side. So I'm going to use tangent. So the tangent of 32 degrees equals the opposite side, which is x, over my adjacent side, which is 13. So my variable is not in my denominator spot. So I know I'm not going to have to divide at the end of this. Woohoo! I'm going to put the tangent of 32 over 1 and I'm going to cross multiply. 13 times the tangent of 32 equals x. And I just have to put that in my calculator. 13 times the tangent of 32 gives me 8.1. So I know this x, this side length, is 8.1. Okay, so let's do another example. We've used cosine, we've used tangent. Let's look at one where we use sine on this. So I'm going to look at this diagram. X is across from my right angle, so it's my hypotenuse. And then from 50.1 degrees, 6 is not right next to it. This is right next to it. This would be the adjacent side. So I know 6 is the opposite side. And since it's the opposite side, I'm going to use sine because I'm looking for my hypotenuse. I know what my opposite side is. I'm going to use sine. And you'll notice that my degree measure is a decimal. That's okay. Just write it in. It's fine. All right, so sine of 50.1. I'm going to do the opposite side, which is 6, over my hypotenuse, which is x. Since x is in the bottom, I know my last step is going to be division. I'm going to cross multiply x times the sine of 50.1 equals 1 times 6, which is just 6. I'm going to have to divide both sides by the sine of 50.1. Crosses out over here, and let's find out what x is. Take my calculator, 6 divided by the sine of 50.1, and it is 7.8. Okay, I couldn't do the mustache anymore. I was digging into my upper lip and my face. See my marks. Anyway, so let's look at if we were going to find an angle measure. So this is kind of like doing the opposite of finding a side, if you'll remember where we did inverses. So I'm going to look at theta here. I'm still identifying my parts. Directly across from my right angle makes 13 my hypotenuse. And since 12 is on the side that helps make up theta right here, 12 is my adjacent side. So adjacent and hypotenuse means I'm using cosine. So the cosine of theta is equal to the adjacent side, which is 12, over my hypotenuse, which is 13. Now, whenever we're finding angle measures, it's the opposite of finding the side measures, and so we have to do inverses. So we're going to do the inverse of cosine. So the cosine inverse equals 12 over 13. And this will give us an angle measure. So remember doing those inverses, we have to hit the second key and cosine. And it'll bring up that cosine with the little -1 on it. So I'm going to type in 12 divided by 13 and hit enter. And I get that theta is equal to 22.6 degrees. So that's how we get our angle measures. We're going to do one more. All right, let's look at this last example. From theta, I'm not using my hypotenuse at all. Not even a thing. So I know I'm going to use tangent. 11.9 is opposite of theta. So opposite, my 10 is my adjacent. So I'm going to use those inverse functions. Tangent of theta equals the opposite side, which is 11.9, over the adjacent side, which is 10. So I'm going to do the inverse of 11.9 over 10. So I'm going to come to my calculator, hit second tangent, 11.9 divided by 10. And I get 49.958. So if I round that up to the nearest tenth, theta is 50 degrees.